Okay, now we're going to get into the weather that actually kind of what we live with, the minute latitudes. So this section is going to focus on what systems impact us in the mid latitudes. So we've talked about the global weather. We're kind of between 60 degrees north and 30 degrees. So we don't have fairly constant high pressures. We don't have fairly constant low pressures. We have a mixture. So we're going to start off talking about air masses. Where do they form? All right. Air masses are basically just a large mass of air. So Arctic air masses form over the Arctic. Continental polar air masses form over Canada, Alaska. These are common in the wintertime. And you think about it, there's snow cover up here, not a lot of moisture up here. What type of air mass is this going to be? It's going to be very dry, very cold. If it comes out of the Arctic, it's even going to be colder. There are maritime polar air masses. They actually form over the northern oceans. Sometimes they can come down over the parts of the area, especially the East Coast or the West Coast, particularly into Seattle, Portland, Oregon area. And they're kind of bring damp, cool weather. They don't bring real cold weather. Now we have the tropics. Maritime tropical air masses form over the Gulf of Mexico or the Atlantic in the tropics. Think about it. If you're along the Florida, you get a lot of tropical weather in terms of really a lot of heat in the summertime, like we're having right now. Our air mass is basically a maritime tropical air mass. Now, if you want to get a really hot air mass, if you notice, they've been having nearly some of the highest temperatures on record out over Death Valley. That's a continental tropical air mass. That's a very dry air mass. Forms over the desert southwest around here. So you can see you can get a continental tropical, maritime tropical, continental polar. They can all come together. And they actually do many times in the central part of the U.S. and even up into your area. What did they come together along? They come together along cold fronts or warm fronts. One of the other things about them, when they leave their source region, these air masses are going to modify. That's a lot of times why maybe up over Canada in the wintertime, you'll see minus 40, minus 50 degrees. When they get down to Ohio, they may only be minus 20. Not that it's warm, but 20 degrees difference is not a bad thing. And by the time they get down to my house in southeastern Virginia, maybe their lows are only going to be in the single digits or even in the teens. So you can see the air mass is modified. Why is it modified? Because underneath it, the ground, we've talked about it, warms up, heats the air above it, causes convection, and that air mass modifies as it's moving along. Now, if there's snow cover, those air masses tend to not modify as much. The maritime tropical, if it's really wet, a lot of heat, a lot of moisture, humidity around, they're not going to modify as much either. So, front slope. One of the things about a front, you can look at a surface weather map here, and that front actually has a slope to it. So in other words, yeah, the cold air is at the surface here, but if you were to go up 4,000 or 5,000 feet, you might actually be in the warm air in this part of Colorado, of Wyoming and Colorado, and South Dakota here. So you can see that there is a slope to these air masses. I could show you it on soundings, but stationary front is just a front that's not moving. So with that slope, remember, warm air, less dense than cold air, so it's going to tend to rise up. So that's why when I was looking at that front there, I said that the warm air was aloft behind the cold front. So if you look for a warm front, you would find that the warm air would be rising out ahead of it, but it would still be in the cold air until finally the warm front comes through. Over here is kind of like a warm front. Not really much of one, pretty much stationary. But even down here, pretty much the front's just dying out, the stationary front. But so most of the precipitation will occur on the cooler side of the front. And on the warmer side, you wind up with, maybe still humid, but maybe not as much rainfall, more of the clouds. And the further up in here, you'll notice they start out as cirrus. And the closer you get to that stationary front, if you were driving along here, you would see your clouds lowering and thickening, and they begin to rain on you maybe. Maybe even some thunderstorms right along the immediate front. So you saw all kinds of stationary fronts on today's weather map. Here's a warm front. Again, most of the precipitation is occurring in the cold, denser air because the warm air goes up over it, causes the rising motion, cooling, condensing, all of that to make the precipitation. Cold fronts, they tend to be a little steeper. Remember, cold air is denser. So it kind of pushes the air up quicker. That's why you have a lot more thunderstorms tentatively with them, maybe. More intense rainfall. Some of the heavier rainfall is going to be along it. Not as long a rainfall. Skies will tend to clear faster. And cold fronts can do odd things sometimes. Sometimes they come what they call backdoor fronts along the East Coast. Had several of them this summer, where they come down out of eastern Canada, work their way through New England and down into the Appalachian Mountains, and they don't ever get back to you if you're in Ohio. And they can really make nasty weather along the East Coast. Occluded fronts are just where a warm front or a cold front has overtaken and pushed a warm front aloft, basically. Or it can happen in either direction. Warm air is aloft, cold or cool air is ahead of it. And you're going to see they happen around low pressures, extratropical cyclones. So one of the other things I want to talk about is frontogenesis, or it's a front is growing stronger. If the cold temperature gradient is increasing along a front, then that front is growing stronger, and it's frontogenesis. Frontolysis means it's weakening. And if you looked at today's weather map, a lot of those fronts are weakening very fast. So with that, you can look at today's weather map here and see that there's a front that used to be along the East Coast here. It's gradually weakening. There was a front coming towards you here in the Midwest. And noticed this front just became a trough. What it did, frontolysis occurred. There's almost no temperature change across it. But in the summertime, along these kind of boundaries, thunderstorms can develop. And here's your other cold front back here, gradually working its way south. So some continental polar air is trying to come in down to your area, but it is struggling to make it this week. Because you saw 300 millibars, most of the flow was out of the west. And once you got down further south, you had that big high, and that is not changing. So as long as that pattern holds, these fronts are going to have a very difficult time making it very far south. Because remember, those fronts are being steered by the upper level winds. They're not being steered by what's happening on the surface. So one of the things you're going to learn about is we have a lot of low pressure systems that go by in the mid latitudes. Every winter you get one. Right now there's some on the weather map. These are extratropical cyclones. They're not tropical cyclones. They're extratropical. I want to emphasize that. Extratropical just means the regular everyday low pressure system you see, where there is a strong temperature gradient along that low initially. Maybe there's that meridional pattern. There would be a stronger one if there's meridional, or zonal, weaker one. Divergence aloft. All that comes together and low begins to form. As the low develops, the cold air gets pushed down by that low pressure. Remember, counterclockwise winds, northwest flow back here, holding the cold air down. Oh yeah, warm winds this way. You're increasing the temperature gradient here. Develop a stronger warm front and a stronger low. Finally, they begin to occlude, and right here is your occlusion. And you see as they get more and more occluded, the actual low winds up back in the cold air. And at this point, it probably isn't deepening anymore. It's not getting stronger. But it's reached its maximum intensity. In the wintertime, you can see almost 1, 2, 3 of these along fronts that stretch across the Atlantic into the United States. And you can actually let one low develop It'll go through each one of these phases till it finally reaches this phase. Another one develops back along that same front that came out of this one, moves through the same set of phases. You may see them in one low in this phase, one low in this phase, one low in this phase, and one low in this phase along the whole Atlantic Ocean or in the Pacific as well. So there's not a lot out there to look at on satellite right now. I thought I'd try to show you something that way, but really there's an extra tropical low. Remember we saw here a little bit of a break in the jet stream, a little bit of divergence in this area, aloft. There's where your low is trying to form up in Canada. Down here you have the big high pressure system trying to allow some thunderstorms to develop along an old frontal boundary down there. Yes, some weakness, mainly along the Appalachians. Pretty much high pressure here. Here's the monsoon beginning to take effect. You actually have moisture coming across this way and up. And you can begin to see some thunderstorms and showers developing in the southern part of Arizona, New Mexico, as the North American monsoon has begun to develop. There's another way of looking at fronts called conveyor belts. So you think about a conveyor belt. We said we had northwest winds behind the front. That's going to be dry, cold, Arctic air maybe coming in. It's going to get mixed into the circulation. When it does, it's sinking behind the front. So it's dropping down, so it's getting even drier. So that's going to cause a dry slot in these fronts. And if you go back to where we're looking at it, you can actually see these dry slots sometimes right on these occlusions, particularly right before it. Right in this area and in this area may all dry out because of this dry, cold air being pulled in and sinking in here. So you wind up having more of the rain and cloud cover ahead of this warm front. And if this dry air can wrap around there, maybe it'll cut the rain off quicker than you would realize, or the snow off. So it is something that meteorologists watch all the time, is these conveyor belts. They're looking for the dry air conveyor belt. They're looking for warm, moist conveyor belts that are rising up, causing the rain to come in, riding the moisture in. So all of these conveyor belts here influence and work together in a extratropical cyclone. So there are various tracks of tropical cyclones. They've been plotted for years. There's an Alberta clipper, which comes literally across the northernmost part of the United States. Typically is flying along, pretty much in a zonal maybe flow or whatever, really fast wind speeds, doesn't last long anywhere. And look where it's trying to find its moisture. It's getting its whatever moisture it had left from the Pacific, maybe a little bit off the Great Lakes, not a lot there. It doesn't have a lot of moisture, but take a Colorado low that came up. Where it's tapping the moisture from the Gulf of Mexico, from the Atlantic Ocean, all of these coming into it. So you look at the different kind of lows labeled here, and they have an impact on how much precip and how long the precip is going to impact your area. One of the really difficult things on forecasting, particularly 3 to 7 days out, you all want to know, oh, is my weekend going to be a mess? Even if it's Monday, you want to know what Saturday or Sunday might be coming up. Well, here's a low that the meteorologists would look at and say models are all conforming it out here. I live in Chicago. I could move this just as easily and say Columbus or Canton. One model track has it coming up, dropping down to the south and coming up on the east side of Chicago. Another one, a little quicker probably, and maybe get out of the area a little bit quicker, but it comes up on the west side. Well, what the heck is that going to do for the impacts on Chicago's weather? If that low comes up on the east side, Chicago is going to be in the cold sector. So it's going to be a snowstorm maybe in the wintertime, or maybe freezing rain or something. It's not going to be nice traveling at all. Man, if I had a big event in Columbus or something, or up in Cleveland I wanted to go to, I'd want to know, am I going to get snowstormed out or not? depending on the weekend. But to be honest, a lot of times, one model might show it coming up just south of that area, and the other one might just show it just west of that area. Look at that. It's only a mile, maybe 100-mile across there. So it's maybe a 100-mile area at 7 days out that we're off by. But that influence, the impact on whether you can make that concert in Cleveland is huge. One other thing with extratropical cyclones. Extratropical cyclones are cold core. That means they get colder as you go aloft, not warm. I mean, not warming much at all. They're most intense at the upper levels. That means, remember, pressure drops faster in colder and denser air. Extratropical cyclones have that. So they're very, very cold in the middle, warmer outside of them. So with that, there's warm core cyclones. Warm core cyclones, if you were to look at a surface weather map right now, and right down in here, in the desert southwest, you'll see low pressure. That's a warm core cyclone. It's warm aloft. It's warm the whole way up. Basically, it's just heating at the ground, making the air spread apart, causing lots and lots of high temperatures. It happens in the deserts a lot, and that's where they generally form. But they're warm core cyclones. They actually, aloft, will become high pressure systems. So you can see the difference. Cold core, extratropical. Warm core anticyclones, on the other hand, weaken with height because they're all warm on the way up. The anticyclones are just the highs that build. They can be warm or cold. And that's where all of your different air masses form. There are some smaller scale circulations, lake and sea breezes. We've talked about those. If you live by Lake Erie, you're going to know about those. If you move down to the Atlantic Ocean or Pacific Ocean, you're going to run into them. There are mountain and valley breezes. If you live in West Virginia, you'll find these breezes occurring out in the Rocky Mountains. And they're huge in determining how to fight fires. All firefighters that fight forest fires understand these winds tremendously, because if they didn't, they may have the fire come back out. There are Chinook and Santa Ana winds, which is just another form of winds coming down off the mountain, gravity pulling that dry air, sinking it, getting drier, getting hotter. And you wind up with very strong winds and possibly tremendous fire potential there. So that's pretty much it for this chapter. Hope you got a little bit out of it, and enjoy your hot weather this week.